Hello, my name is Albert Mduduze Khelesi. I'm a BEng Tech Electrical Engineering student at Central University of Technology. Right now I'm about to present my project. So the project name is a smart intrusion detection system. So the research question regarding this project is how accurate are ultrasonic distance sensors and PIR sensors in detecting different intruding objects within a specific distance range under varying temperature conditions. So yes, temperature is going to be considered in this case. Now when it comes to my test intruders, for the test intruders we have the following. So the first thing that I'm going to use is my hand. I'm going to use my hand, and then I'm also going to use the steel pot. I'm going to use the double cup, the double plastic cup. I'm going to use the sponge and also a plastic container with boiled water. So these intruders, I will bring them closer and see how they trigger the sensors. I will start listing the components this breadboard consists of. We have the PIR sensor for motion detection. We have the ultrasonic sensor for distance measurement. We also have the DHT11 for temperature determination. The green LED is for feedback that the ultrasonic sensor senses an intruder within 30 centimeters. The red LED tells us that while the distance of the intruder is detected within 30 centimeters, there is motion or not. When both LEDs turn on, that means there is motion and distance is within 30 centimeters. We also have the ESP to send data to the cloud. As you can, I can also show you. So this is the data I already captured on the previous days. Going back to the breadboard, I also have the relay switch right here, which is going to turn on the LED or a bulb, right? We also have the servo motor. So this servo motor will lock once the buzzer goes on, and also once this buzzer goes on, the servo motor will lock. So the first intruder that I'm going to test is my hand. So let's see at what distance is my hand going to trigger the sensors. So we see that in this case it was triggered at 16.18 centimeters. So now the next intruder that I'm going to test is the steel pot. Let's bring it closer. As we can see, the ultrasonic sensor was triggered, but the PIR was not triggered. If we look at the serial monitor, we see that it was triggered at 23.85 centimeters. Now let's bring it closer and see if it's gonna trigger the PIR sensor. As we can see, the steel pot didn't trigger the PIR sensor. Now the next intruder that I'm going to test is the plastic cup. So let's bring it closer. As we can see, only the ultrasonic sensor was triggered. Let's check at what distance. So it was triggered at 25.25 centimeters. Now let's bring it closer and see whether it's going to trigger the PIR sensor. As we can see, the PIR sensor was not triggered also in this case. Going to the next intruder is going to be the sponge, right? As you can see, we're gonna bring it closer. Bring it closer. You can see that with the sponge, none of the sensors were triggered. So now our next intruder is going to be I've boiled water inside this plastic container. Now let's bring it closer and see what's gonna happen. As we can see, both the sensors were triggered. And then when we look at the serial monitor, we see that the distance is 23.61 centimeters. So far, this is the data I managed to collect. I also send it on ThinkSpeak. I still have to take some data on different temperatures. So the recorded data shows specific triggering distances and how these change with temperature, highlighting the system's sensitivity to environmental conditions. The buzzer provides alerts when both sensors are triggered, making this setup effective for studying intrusion detection accuracy and environmental influence. Yes, so this is where my presentation ends.